In this video, I want to offer up a brief introduction to adding and subtracting polynomials. Now, the key to doing this is combining like terms. Well, what are like terms? Well, any terms that have the same variables with the same exponents on those variables are considered like terms. All right, well, we have three terms right here, and it seems like all of them have the same variables, x and y. But none of these are like terms because the exponents on those variables are all different. The squared in this case goes with the x, the squared in this case goes with the y, and in this final case there are no exponents on the variables other than just the ones. Okay, so none of these three terms are like terms. So what would I have to do to this last term, this 6xy, to make him a like term of the 5x squared y? Well, you'd have to add a squared right there on the x, and now these two are like terms. They have the same variables and the same exponents on those variables, so x squared and y. Okay, well, let's do a quick example here. So we'll do it with just a single variable first, and I want to point out a couple of things. Okay, so 3x squared plus 5x squared minus x squared minus 4x squared. You'll notice in this case all of these terms are like terms because they all have x as their variable, and also all their x's have a 2 for the exponent, so x squared are all the terms. Okay, so how do I combine like terms? Well, I'm going to focus on their coefficients. Remember, that's the number out front. It tells how many we have. Okay, so in the first case, this coefficient is 3, and then positive 5. And in this case, I don't have a number written explicitly out here, so it's understood to be a 1, so I'm going to sneak a 1 in there, and then I have a negative 4. So when I'm combining these, I'm really focusing on adding and subtracting their coefficients because all of them already I know are like terms. So one way you can write this is by focusing solely on the coefficients, 3 plus 5 minus 1 minus 4, and all of those terms are x squared terms. So 3 plus 5 is 8, minus 1 is 7, minus 4 more is 3, and then the x squared comes along. So this would be the simplified version for this expression. So one common mistake that I want to point out that students often make, let's just look at these first two to begin. So we have 3x squared plus 5x squared. This is not going to be equal to 8x to the 4th, okay? So when you're adding and subtracting like terms, the variables and those exponents on the variables do not change. All we're doing is combining the coefficients. So that is a common mistake, so don't be caught making that mistake. So 3x squared plus 5x squared is 8x squared. In this example, it looks like we have this first polynomial. He is going to be a quadratic trinomial, and we're going to add to it another quadratic trinomial. Okay, so typically when we see parentheses, we kind of want to distribute something into those parentheses, except out front of the second pair is just a plus sign. So one thing that's nice about adding polynomials is if you're just adding right here, you're not distributing any numbers or anything, you can just lose the parentheses. So I'm going to go ahead and just scratch these out, and so I can focus on just combining like terms. So the like terms again will be the terms with the same variables and the same exponents on those variables. So here I have x squared terms, so 4x squared plus, and again this is 1x squared when no coefficient is explicitly written. So 4x squared plus 1x squared will be 5x squared. Okay, so our x terms now, we have a positive 7x, and we're adding to that a negative 7x. Well, positive 7 and negative 7 are opposites of each other, so when I combine these, I actually have 0x. And one other common mistake students will make is they'll go ahead and put plus 0x, but if there's 0 of them, we don't need to write him in the final answer. He does not need to be included. So positive 7x and negative 7x cancel, and we're done. We don't need to put them anywhere else. And finally, we have this negative 3 and positive 9. So negative 3 plus 9 is positive 6. So here will be my final answer. And I've written it in standard form, and it was easy because both of the polynomials that were given to me were already written in standard form. The big difference between adding and subtracting polynomials is this negative out front here. Obviously, it means subtraction instead of addition, but we will treat it just slightly differently than addition, because remember, with addition, we could just lose the parentheses. This is not the case with subtraction. So what we're going to do, we're actually going to turn this subtraction problem into an addition problem, and then we can lose the parentheses. So we'll do so by taking this negative and distributing him through the polynomial that's following, or this set of parentheses here. Essentially just the distributive property. So what I'm going to do is write down that first polynomial, so 11m squared minus 3m plus 8. And what this looks like now when I distribute the negative, I'll have a negative 5m squared plus 2m minus 6, because the negative will just change the sign of all of these terms. Now I'm prepared to combine like terms. So 11m squared and negative 5m squared, well, they both have the same variable and the same exponent, so I know they're like terms. And 11 minus 5 is 6, so I'll say 6m squared. And then we have negative 3m and positive 2m. So negative 3 plus 2 is negative 1. But I don't need to write the 1 in front of the m. Remember, it's understood to have a coefficient of 1 if I don't write any number. So since it was a negative 1, I'm just going to write negative m right there. And again, that's understood to have a 1. And then finally, a positive 8 and a negative 6. So 8 minus 6 is positive 2. So I'll say plus 2 on there in the end. And again, both of these polynomials were given to me in standard form, so it was easy, and this last one is already written in standard form. In this last example here, it looks like I have 3 polynomials. All of them are trinomials, but the first one and the last one are cubic, and the middle one is quadratic. So not all the degrees are going to be the same here. And we also have addition and subtraction. So what we're going to do first is go ahead. On the addition, we can just lose the parentheses. And on the subtraction, we need to distribute that negative, and then we can lose the parentheses. So let's go ahead and write all of these terms now correctly without any parentheses. So 8n cubed plus 2n minus 3. And then here, we can just lose the parentheses in the addition sign, so it becomes just minus 3n squared plus 5n minus 2. And then when we distribute the negative, negative 5n cubed plus 4n squared minus 9n. All right, so now we have our work cut out for us. Let's go ahead and start with the highest degree term and work our way down so we can write this in standard form. So 8n cubed, the exponent of 3 is the highest degree here, so n cubed. Are there any other n cubed? Right here is another n cubed term. So 8n cubed minus 5n cubed. So we're going to combine those coefficients. 8 minus 5 will be 3, and that n cubed will stay the same. Okay, so I'm kind of done with those now. So the squared will be the next highest degree term. So I have negative 3n squared, and here's another one with positive 4n squared. So negative 3 plus 4 is going to be 1. So plus 1n squared, but I don't need to write that 1, so I'm just going to say plus n squared. And then I'm done with those terms. Okay, so the n is the next. So I have plus 2n, and then a plus 5n, and then a minus 9n. So positive 2 and positive 5 make positive 7n, and then minus 9 is negative 2n. And finally then I have a negative 3 for a constant and minus 2. And that's all those. So negative 3 and negative 2 make a negative 5. So we have now simplified this by adding and subtracting these polynomials as the problem deemed. And we went ahead and wrote our final answer in standard form. So remember, the big takeaway here, like terms are any terms that have the same variables with the same exponents on those variables. And when I'm adding polynomials, I can just lose any parentheses that exist and just combine like terms. And the only difference for subtraction is I will distribute that negative sign, turn it into an addition problem, and then go ahead and combine like terms.